In the end of this video, you will be able to make a dynamic jumping system like this, in which the jumping system will also respond to our falling impact. So before we really do anything here, I've already used the ProBuilder plugin to make a simple testing range for us, so that we can, test out every feature we wanted. So after setting up the testing range, we're also gonna fix our old camera stuttering effect and optimize our code a little bit. So last time we had this very weird camera stuttering effect when moving and rotating our camera simultaneously, and we're gonna fix it. Go to our player controller. As our first step, we're gonna zero out our player target speed completely if the player is not pressing anything, and that's it for our move function. And secondly, for our camera movement function, instead of using transform.rotate, we're gonna rotate our rigid body instead. We're gonna multiply our current rotation with a new quaternion. And instead of using time to delta time, we're gonna use time to smooth delta time instead. And also change this one to time to smooth delta time. And that's it. Back to our Unity editor. In our rigid body session, remember to uncheck our freeze rotation constraint so that we can actually rotate our rigid body. And that's basically it. Now you can see this really smooth camera rotation without stuttering. As our first step, we need all of the necessary animations. In Mixamo.com, we need to download the animations for our jumping state, falling state, and landing state. As usual, click Download, FPX for Unity, without skin, and download. So after we've downloaded every animation we needed, we simply need to import all of the animation we just downloaded and set them up. Choose humanoid and then copy from other avatar. And for the avatar definition, we're gonna choose the avatar we created last time. Apply. And then proceed to set up all of the animations. When setting up the animation, make sure the model is actually touching the ground. After doing all of that, back to our Animator controller. So first of all, I've created 3 more parameters for us to use. 2 boolean parameters, another trigger parameter. One called falling, another called grounded, and the final trigger parameter is called jump. So, using these 3 parameters, we're gonna create the separate animation states for them. We're gonna create 2 empty states, and then create the final one from blend tree. For the naming part, I'm gonna name the first one jump, the second one falling, and finally the third one landing. Land. For the next step, we're gonna feed our animation into the motion field. And we're not going to do anything to the landing blend tree yet. Right, and then finally make the corresponding transitions for each of our animation states. Don't forget to make another transition from base state to falling state, as our player will sometimes decide to, walk off an ledge. Then populate all of the transitions. From base state to jump state, we want the trigger jump to be triggered, and then also uncheck has exit time. From base state to falling state, we will also want to uncheck has exit time. And then for the condition, we're going to use falling equals true. And finally, from falling to landing blend tree, we're going to set grounding equals true, and then also uncheck has exit time. And that's basically it. Alright, just a side note, when I was editing this, I found a serious flaw that makes the animation more, jittering. Basically, what you want to do is just, for the transition from jump to falling, since we have has exit time checked, you want the animation to be playing like about this length. I remember the default one is a lot longer. It's something like this. You don't want that. You want the animation has exit time to be as short as possible while keeping the interpolation smooth. And for each of the animations, you want them to be set up exactly as this. So for falling state, it's like this, while for jumping state, it's like this. Otherwise, the gravity isn't gonna, work correctly for the root motion. Back to our scene view. So in order for the system to know that the player has pressed the space key and then trigger a consecutive, reactions of the whatever jump action that is, we'll also need to modify our input action map. So for the last tutorial, we've already created one, and what we're gonna do is just create another input action. We're gonna name it jump, and for the action type, it's gonna remain button. For the interaction parts, we can modify the interaction to tap, but this one is really optional. Alright, and finally, for the binding, we're gonna bind it to space key. And that's it. After modifying our input action map, we're actually gonna change our input manager a little bit. For our input manager, we're gonna create another read-only and exposed field for our player controller to know that the player has pressed the jump button. I'm gonna start with public bool and call it jump. And next, create a getter and setter. Make sure it's read-only. And then for the input action, I'm just gonna call it jump action. Make sure you actually instantiate the jump action. So by doing that, current map.find action and jump. So like what we did before, we're gonna create another callback function for our jump input action. And name it onJump. And set the jump value to the context value. By the way, if in the input action map, you choose the jump key to be a tap interaction, make sure you have this using Unity engine.inputsystem.interactions. And then we're gonna write if context.interaction is tap interaction, and then execute the following statement. This will ensure the function is only called once when the player pressed the spacebar. And finally, once we've created the callback function, we're gonna attach our callback function to our jump action. And that's it. So, before moving on to making the actual logic for our jumping, we need to lay some ground rules here. Well, first of all, suppose this is our character, and the shell outside of it is our capsule collider, and our character is currently standing on the ground. When the player has pressed the space key, we're gonna apply an impulse directly on top of our player. So, suppose our player has successfully levitated. Due to the rigid body component attached to our player, the player is gonna feel a downward acceleration of gravity. And then, this is the most important part. We're gonna cast a ray right from the middle of our player, directly downward, and exceeding our capsule collider just by a little bit. So if the ray has collided with the ground, the player will be grounded. And then play the following landing animation. And in the end, the player, once grounded, after playing the landing animation, it's good to perform the jump again. And that's basically it. So, after the ground rules has been laid, let's start the coding. Start creating the animation hash IDs. That's it. And then remember to find the hash IDs from our Animator controller. Done. In the end, to handle our jumping sequence, we need to define a method called handleJump. Same as before, if our player doesn't have the component Animator, we're not gonna run this method. And then, if the player has not pressed the jump key, which is the spacebar, we're also not gonna run this method. And finally, if all of the conditions are met, we're gonna play the animation. We'll first enter the jump animation. Alright. The last step is to actually run the handleJump function in our fixed update loop. Now if we press the spacebar, the animation will play correctly. And it's time to move on to our levitation logic. You might be thinking, the solution might be as easy as adding a simple add force statement here, but that will result in the player levitating before the animation has started. So to fix this problem, in our jump animation, scroll down to the bottom, in the event section, click add event, and then navigate to the point where the player is about to jump, but hasn't lost contact to the ground yet. I think about here is fine, and then drag the animation event to that place. I'm gonna name the function jump add force. Click apply, and we're all set. Back to our player controller, we need a method called jump add force, and the method must be public so that our animation can actually read from our player controller script. Make sure you have the spelling correct. And then what we're gonna do is just simply, for our player rigid body, we're gonna add a force directly upward, so factor 3 dot up. We're gonna multiply it by a factor called jump factor. And then for the force mode, we want it to be an impulse. That's it. Scroll to the top of the page. We're gonna create a serialized variable called jump factor to control the extent of our jumping. Now, what you want to do is that you want to tweak this jump factor in the play mode so that the player can reach exactly the height wanted or a little bit above that. If the player is jumping too high, just lower the jump factor. And if the player is jumping too low, just higher the jump factor. And I think this works for me. So after selecting your favorable jump factor and tweaking all of the jumping animation and stuff, you probably think we're all done.
But I'm not done yet!
The jumping animation on the playing ground looks like this. However, jumping on an incline slope will yield a lower jump height. But this is primarily because that the rigid body component attached to our player has a constant gravity on our player, and hence on a slope, our player will have a downward velocity. Our jumping force will need to be much more greater to combat this jumping velocity to cancel this out so that we can achieve the same height as before. In order to do that, just before we add a force to our player rigid body, we need to add another force to cancel out the downward velocity. So what we're gonna do is just detect the current downward player rigid body velocity and then use that to add a force directly upward. And for the force mode, we're gonna use velocity change. Alright, that problem is solved. Now we're done with the basic jumping logic, we can proceed to do the landing logic. We're just gonna create a method called sample ground. And all this method is going to do is just basically cast an array from the middle of the player and downward and see when does the player collide with the ground. And same as usual, if the player doesn't have the animator, we're not going to run this method. And then this is the most important part, we're going to cast the array directly downward. Since we have access to our rigid body for the array origin point, we can actually cast it from the center of mass of our rigid body. So we just basically do row center of mass and then cast the array directly downward. So vector 3 dot down, output point, so and then ground plus EC a little bit, and then finally the layer mask. And finally for the layer mask, I'm just gonna create a layer mask called ground check. Right, and let's go on to create all of the variables we needed. Alright, so within this bracket, it means that we have basically collided with something. And it also means we're grounded. And outside of these brackets, it means we're floating or falling. Right. So for our grounded logic, we're gonna first create another flag called grounded. We're gonna set our grounded to true. And outside of the brackets, when the player is falling, we're gonna set grounded to false. And I'm also gonna proceed to create another method called set animation grounding. And And within the method, we're going to modify our animation parameter, which is falling and grounded. Since grounded and falling is exactly the opposite concept, when setting the animation, we can just simply do the reverse in each animator, and then call this setAnimationGrounding function in our sampleGround function. And the same logic applies when the player is falling. And finally, we're going to run a return statement in both grounded and falling session to prevent the game from executing the falling code when the grounded code is finished. So now our game is running with a bug in which the jumping trigger doesn't reset after each cycle and then triggering 2 jumps together. To fix this, we're going to navigate to the end of our addForce method and then use animator.resetTrigger. Alright, now you can see our jump trigger is resetting correctly. Since we not yet have any animation for our landing session, Unity is just going to play the T-pose animation as a placeholder. So next, we're going to find some landing animations. Now, for our realistic jumping system, we need 2 kinds of landing animation. The ones that involve player movement and the ones that don't. In the last tutorial, we had a testing project where we're going to test out every third-party asset, which is this one. And we've also imported the Unity's starter asset, third-person controller here. And we're also going to need some of the animations within the asset. So once you imported the starter asset, navigate to starter asset, third-person controller, character, and animations. We're first going to need the animations that involve player movement, like this one. So we're going to choose this one, and then this one. We're going to right-click and export package. Uncheck the model since we already have it, and export. I'm just gonna name it animations. Once you've exported the package, go back to our default project. Import the package we just created, and import. Alright, now we're just gonna move all of the animations back to our animation folder. Since this folder is already empty, I'm just gonna delete it. Now, for the animations that doesn't involve player movement, we're gonna go to mixamo.com, searching for landing. I'm gonna download this one, FBX for Unity, and without skin. Download. Alright, that's the hard landing. And now for the normal landing, you're gonna trim the animation until the animation doesn't have any vertical movements. This looks good for me. Download it. Alright, so back to our project, and go to our animation folder. I'm just gonna create a new folder called Jump. Put every animations into the jump folder, and then we're also going to import the animations we just downloaded. Alright, now it's time to rig all of the animations. We don't need to rig the animations we just imported from the Unity package because they're already rigged for us. The only thing we need to rig is the animations we downloaded from Mixamo. And I'm just going to rename all of the animations. Alright, it's time to set them up. Alright, now it's time to set up our Animator controller. Go into our landing blend tree. For the blend type, we're going to choose 2D freeform Cartesian, and then add a lot of motion fields. Now import all of the animations we just imported. Alright, we're basically all done. So according to our concept, we also need to calculate the impact of our player. And hence, we need the player's current falling velocity. I'm just going to name it Z velocity. Right. For our vector parameter, I'm just going to use Z velocity and then Y velocity. The Z velocity accounts for how fast the player is falling, and the Y velocity accounts for how fast the player is advancing forward. And the dynamic running system should incorporate these parameters because the player should have different animations if the player is running at different speeds or falling at different speeds. And then it's time to set them up. So you can really use any values you want, but I personally tested these values and they really work for me, so I'm just gonna use them. Alright, in the end you should have something like this. Now the blend tree should account for both our impact and our running velocity to create a more realistic jumping system. Now we're done setting up our blend tree, but we still have more things to do. First of all, for our running and landing animation, they come with a default landing event. We're just gonna delete them. Click apply. And this one, delete them, click apply. And finally, this one. Delete it, click apply. And lastly, we also need to send our Z velocity, how fast this player is falling, through our player controller. Go back to our player controller. We're gonna create a corresponding hash ID for our Z velocity. That will suffice. And then we're also gonna find a corresponding reference in our Animator controller. And finally, we have to set a Z velocity. We should set it in falling state because when player is falling, that's when the player's Z velocity is accumulating. So in our falling statement, we're gonna add animator.setFloat, our Z velocity hash ID, and then our player falling velocity. Our landing system should now account for both our player current velocity and the player's falling velocity. But meanwhile, you maybe notice that our player is able to move in air. That's because we didn't disable our move function while the player is jumping. So head back to our player controller. We're first gonna see if the player is grounded. So when player is grounded, we can actually move the player, and if the player is in the air, we cannot move the player. Right, let's just move all of the code inside. And then when the player is in the air, the player should not be able to move. And then there should be also a presence of air resistance. So you want to do that? First thing you want to do, player light, half force. So what we're gonna do is just basically multiply our current velocity by an air resistant constant. Alright, for force mode, we're also gonna use velocity change. And that's it. And let's go on to create another variable called air resistance. So now the player should not be able to move when moving in air. By the way, if you still don't get these animations right, just try to tweak the animation blending statement and then try to tweak the animation themselves. If you're still struggling, I've already posted my project link onto GitHub so you can look them up and get my original project. Bonus clip, I'm gonna teach you guys how to make b-hop animations. So currently, if you were to press spacebars continuously, you found that the animations are really jittery and it's actually quite impossible for us to b-hop around. This is because when the player is transitioning from jumping state, the player has to go through falling state and then to landing state. And then in the landing state, if the player has pressed the space button again, the player has to go through base state and then to the jumping state. This extra layer complicates the whole animation. And instead, what we're gonna do is just make a transition directly from jumping state to landing state and make a transition directly from landing state to jumping state. For the transition from jump to landing, the grounded parameter should be true. And from landing state directly to jumping state, the jump trigger should be triggered. And also remember to uncheck the has exit time box. And finally, I forgot to mention this earlier, but for the transition from jumping to falling, and for the transition from landing to bending, the interruption source should be next state. Back to our player controller. So now, if we really want the b-hop animation, there's a trade-off here. For the b-hop animation, since we're transitioning directly from jumping to landing, this method is not actually executed, and hence the player is not really jumping up. So to fix this, all you're gonna do is just basically copy and paste all of this to here. You can see that our player can b-hop now.